As you see, this time we will use washer method, or my question will be about washer method and cylindrical shell method. In the last session, I was talking about cross-section method. We're done with the cross-section. And we're done with disk method. Today, as you see, we have washer and we have cylindrical shell. Let us start with the first question and how I will know if my question is disk or washer. Find the volume of the solid obtained by rotating the region bounded by the curve y equal x square. As you see, very easy to graph x square, almost like this, x square. And the line minus 3x plus 4. So we have 1, 2, 3, 4. And since it's negative, almost the graph will be like this. So my region will be this one between the curves. I didn't say in the first quadrant or in the second quadrant, so this will be fine. So this is the one point, this is another point, and my revolving will be about x-axis like this. So that's mean the shape will be almost, I'm saying, 1, 2, 3, 4. Maybe I can use a light color. And this will be revolving like this. This will be revolving like this. And the shape will be like this, etc. Okay, how we can find the solid? By the way, from here will be empty, from here will be empty. So that's how I know that we should use washer method. And definitely I have two functions, one function here, one function here. For me, first of all, I should find this point and this point. How I can find these 2 points? X square equal minus 3x plus 4. Flip this to the other side, x square equal, oh, sorry, x square plus 3x minus 4 equal to 0. Modify the 3 by calculator, or x plus 4 and x minus 1 equal to 0. From here, x equal minus 4. From here, x equal 1. So this will be minus 4 and this will be 1. X equal 1. X equal minus 4. So my integration, the volume will be what in washer method? The integration from a to b. Let me say F capital or R capital, it's up to you. I prefer R capital of X square minus R small square of X. Since we have rotating, that's mean by R, so by here. In the last lecture, I was using half by accidentally, sorry for that. I write in the video that there is no half here. So this will be the integration from the start point minus 4 to the end point, which is 1 by outside. The upper function, it's clear this function, which is minus 3x plus 4. The lower is this one, which is x squared. So we have now minus 3x plus 4 all square minus x squared. Everything here is square. Equal, catch your calculator and put the final answer here. Today, I don't have the answers, but to make the videos shorter, I will ask you to fill this place by calculator. Minus 4 the start point, my plus 1 the end point, upper minus lower, so this will be empty here. This will be empty. This from here will be empty, but again I have this and almost this, and each one it's revolving like this and like this. So this revolving here and here and here. I hope that the shape is clear for you. I hope you got the idea. This question by using washer method. We find the intercepts. Then my integration r capital square minus r small square by outside the bounded here. Another question with the same idea, I believe, washer method. So one more time, the graph helped me a lot. Y equal the root of cosine x, y equal 1. I will start with this first. Y equal 1, horizontal line. Y equal 1, x equal pi over 2. Let me say this is x equal pi over 2. In the first quadrant, that means I don't care about anything here and here and here. So only here, y equal cosine, y equal the root of cosine x. So my interval clear since it's in the first quadrant from 0 to pi over 2. Substitute 0 in this equation, cosine 0, 1. So root of 1, 1. And cosine pi over 2, it's a 0. So my function almost like this. You can substitute dots here and here. If you don't know how to graph the function, it's completely correct. So where is the region that I will make revolving for it? This is my region. Different color is better. I think red is good. Oh, delete everything. One more time. This is my, oh, we say this one should be in red. No problem. Now we have problem with this question. I ask about x-axis and I should write another about here, y-axis. So it seemed like not one question, two questions. This will be A, this will be B. A, by revolving about x-axis, that means like this, the revolving. So the shape will be something like this, something like this. This will be empty here, by the way. Okay, this will be upper, this will be lower for x-axis. So now we have volume, washer method again, washer method. V equal the integration from this point to that point, which means from 0 to pi over 2. The upper function is 1, so the upper function or our fate by here. First function, or let me know, it's better if I write the formula first, sorry. A, B, R capital of X, then minus R small square of X dx, which mean by the integration on X, this will be the start point, which is 0. This will be the end point, which is pi over 2. So from 0 to pi over 2. R capital, if I'm looking from up to down, this will be the upper, this will be the lower, as you see. So the upper function is y equal 1. So 1 square minus r of x. The function here is what? Y equal the root of cosine x. So the root of cosine x, don't forget square dx equal, fill this by your own calculator. This is not everything because we want to solve this question again. This time I say about y-axis. The shape would be like this, by the way. About y-axis now. So about y-axis, v equal the integration from c to d r capital O square of y minus r small square of y, and here dy. It's not an easy question now, but I believe you will understand it. This is my y1, this is my y2. So my y1, it's still 0. y2, it's 1. So my integration will be from 0 to 1, and we forget the by here. This for me will be the upper, and this will be the lower. If we look from y, this will be the upper, this will be the lower, this to the right, this to the left. It's up to you how to understand this. This function, x, and we need it per y, x equal what here? Pi over 2. So this will be pi over 2 square. Now this function, it's y equal the root of cosine x. So y square equal cosine x. So x equal, I know many of you, they believe it's a weird question, so it's not a weird one. Cosine inverse y square whole square. So x equal, x2 equal, dy, catch your calculator, what's the final answer here? Okay, I hope that you get the idea. One more time, we have x-axis. With x-axis, this would be upper, this would be lower. With y-axis, this would be upper, this would be lower. With x-axis, y equal, y equal. With y-axis, x equal, and the other x equal here. X equal and x equal. One more question, and again, this time we have A and B. A and B are x-axis and y-axis. So with x-axis first, this is my function and this is the bounded. Since we have a graph, everything is easy. So A equal, my revolving will be on x-axis like this. No one function, and I got the solid, no space, so that means this could be by this method. Good revision for the previous lecture. V equal pi, and this is my radius, or this is the highest here, or here, or here, and usually we have f of x square dx, the integration from a to b. In last lecture, I add half here by mistake. My start point is 1, my end point is 5, pi, and my function minus x squared plus 6x minus 5 square dx. I believe this will be a very easy question. Since I have a start point, I have the end point, then my revolving on x-axis like this, like this, like this. So almost will be like this. Okay, we will use the same graph, but now B. With B, we have the revolving about y-axis. So my revolving will be like this, and like this. So my shape will be like a donut, something like that. That's mean we cannot use washer. This is my left, this is my right. Left and right is the same function. So if I use washer method, the answer will be 0, but we have the volume here. So since I cannot use the washer method here, so that means this will be cylindrical shell. Okay, with cylindrical shell, the most important things is the highest and the radius. This is the radius. Come on. So V equal the integration from A to B. This is my A, the start. This is my B, by the way. 2 pi r of x and h of x. We write radius and we write highest, dx. Okay, I want the shape staying with me, no problem. Okay, so 2 pi outside. The integration start point 1, end point 5. So 1, 5. The radius is this distance from this point to here and here and here and here. See with me here, 1, it's the value of x. Here 2, it's the value of x. Here 3, it's the value of x. So this will be x without any change. Not x plus 1, not x minus 1, only x, because the distance from here to here 1, as you see, it's the same number. From here to here 2, same number. From here to here 3, so nothing to add it. The highest is the function f of x, which mean minus x squared plus 6x minus 5 dx. Now we have integration, multiply this 6 here and here and here, or you can put it only in the calculator. 2 pi, the integration from 1 to 5, minus x cubed plus 6x squared minus 5x dx, and the calculator will give you the final answer. I hope everything is clear. Already we have the graph, we know the start point, we know the end point, and here it's the radius, So when we make a circle here, when I make another circle with here, and the last circle, I will make it revolving about y-axis. So this will be the radius. As you see, distance from here to here, it's a 2. From here to here, it's a 3. So the x will be x, not x plus 1, not x plus minus 1. And clearly the highest will be, this is the highest at this point, this is the highest, this is the highest. It's minus x squared plus a 3x minus 5. This is the answer with cylindrical shell. And now find the volume again. But now we don't have a graph, so we should find it. So I will take negative outside. X squared minus 4x plus a 3, x minus a 3, x minus 1, negative. From here, x equal to 3. From here, x equal 1. So this is my 1, 2, and 3. Since we have a negative, so the function will be down the parabola, something like this, almost. And find the volume of the solid between the curve, this one, and x-axis. That means this is my solid. And this revolving about the line x equal minus 1. Here is x equal minus 1. So the revolving will be not on y-axis. So this will be not revolving like this. No. Yeah, it's like this. So this one will be 1 minus 2 minus a 3 and minus 4. So the revolving will be like this is not correct. I say that again. The minus 1 will be 1, 2, 1, 2 will be with minus a 3 like this. the 3 will be 2 more, that's mean 2 minus 5, like this. So the center here, it's x equal minus 1. As you see, my x here, it's not 1. The distance from here to here, it's not 1. The distance from here to here, 2, or the length from here to here, it's not 2. It's 2 plus 1. So all the time there's a plus 1. So this is not 3, because this would be 4. That's why and we will use cylindrical shell method. The integration 2 by outside, or I can make it inside, later I will take it outside, from A to P, and one more time, R of x, h of x dx. This means the integration will be from where to where, my start point here, my end point here, so I will start from 1 till 3. 2 by, I can make it, I say, outside, but no problem. Again, it's inside. The radius here, it's not x, because the value of 1 here, the radius will be not 1. At the 1, the radius will be 2. At 2, the radius will be 1, 2, 3. At 3 will be 4. That means x plus 1. The highest, it's very easy in this case. This is my highest. And the highest here is the function minus x squared plus 4x minus 3. So I will write here minus x squared plus 4x minus 3 dx. So this will be 2 pi outside, the integration from 1 to 3, and 2 function here, x plus 1, x minus x squared plus 4x minus 3. Put it in the calculator, or if you want to solve it manually or by hand, multiply first time first, first time second, first time third, second time first, second time second, second time third, then make the integration, substitute upper minus lower. But as I say many times, with volume, area, the application, you can use the calculator to get the final answer. This was almost all the ideas, almost I'm saying, because maybe here we have one more idea about y-axis, but I didn't include it. I hope that you understand the main concept of how to find volume. In the last session 3, we talk about cross-section disk method. In this, we talk about washer method and cylindrical shell method. See you next video.